Good morning, everyone. I welcome you all for next lecture class. So, in this class, we are going to discuss about stepper motor. So, stepper motor, we know that the motor or a step motor is a brushless synchronous motor which divides a full rotation into a number of steps. That's why it's called as the stepper motor. So, unlike a brushless DC motor which rotates continuously when a fixed DC voltage is applied to it, a step motor rotates in discrete step angles. The stepper motor, therefore, are manufactured with the steps per revolutions 12, 24, 72, 144, and 180, and 220, resulting in stepping angles 30, 15, 5, 5, 2.5, 2, and then 1.5 degree per steps. The stepper motor can be controlled with or without feedback. And this is the stepper motor diagram, that is which consists of shaft, front end gap, rotating sections, magnet, and rotating sections, rear end gap, and stator winding bearings. So, working of stepper motor works on a principle of electromagnetism. There is a soft iron or magnetic rotor shaft surrounded by a electromagnetic stators, and the rotor and the stator have poles which may be teethed or not, depending upon the type of stepper. When the stators are energized, the rotor moves to align itself along with the stator in case of permanent magnet type stepper, or moves to have a minimum gap with the stator in case of variable reluctance stepper. This way, the stator are energized in a sequence of rotate the stepper motor. And as the overview of pictures are there. So see the stator and the rotor like a gear with the teeth. So already I mentioned, and the stator consists of the poles. I think 8 poles are there, and in centrally it has a rotor which is, shows like a gear. So type of stepper motors are variable, permanent, and then hybrid. So again, variable reluctance motor divided into two parts. The two type of motors are there. One is single stack variable reluctance motor and multi-stack variable reluctance motor. So type already discussed here. Permanent magnet stepper motor rotates that are constructed with the permanent magnets which interact with the electromagnets of the stator to create rotation and the torque. A permanent magnet stepper motor usually have comparatively low power requirements and can produce more torque per unit in input power. So second one is variable reluctance motor rotates are not built with the permanent magnets rather than the constructed with the plain iron and resemble a gear with proteus or teeth around the circumference of the rotor. The teeth lead to wear steppers that have a very high degree of angular resolutions. However, this accuracy usually comes at the expense of torque. And the third one is hybrid synchronous stepper, which is rotate use the best features on both the permanent magnet and variable stepper motors. The rotation in the hybrid motor has a permanent magnet core, while the circumference is built from the plain iron and has teeth. The hybrid synchronous motor therefore it has both angular and resolution and high torque. So we're going to see the step angle. So step angle is defined as the angle at which the rotor of a stepper motor moves when one pulse is applied to the input of the stator. The positioning of a motor is decided by the step angle, and it is expressed in degree. The resolution of the step number of the motor is number of steps is mixed in a one revolution of the rotor. The smaller and the step angle, the higher the resolution of the position of the stepper motor, the accuracy of the position of the objective The motor depends on the resolution. The higher resolution gear will be accuracy. The standard motor will have the step angle of 1.8 degree with 200 steps per revolution. The various step angle like for 90, 45 and 15 degree are common in simple motors. So we have a calculation for the step angle. The formula is phi is equal to ns minus nr divided by ns minus nr into 360. We know that phi is the step angle, ns is the number of teeth in the stator, and nr is the number of teeth on the rotor. So step per second is equal to rpm into pi into 60. Stepping motors have three types. One is full step, half step and micro step. So full step is standard hybrid. Stepping motors have 200 rotor teeth or 200 full step per revolution of the motor shaft. Dividing 200 steps into 360 of the rotation equals to 1.8 degree full step angle. Normally full step mode is achieved by energizing both windings while reversing the current alternately. And half step simply means that the step motor is rotating at 400 steps per revolution. In this mode, one winding is energized and then two windings are energized alternately, causing the rotor half step degree in the are 9.9 degree. And although it provides approximately 30 degree less torque, half step mode produce a smoother rotations and full step mode. And third one is microstep. Microstepping is relatively new stepper motor technology that controls the current in the motor winding to a degree that further subdivided into the number of positions between poles. It is typically used in the applications that requires accurate positioning and smoother motion over a wide range of speeds. Like the half-step motor, microstepping provides approximately 30 degree less torque and then full step mode. It shows in the full step, half step and then micro step in the picture. So application of stepper motor using an input pulse, they are suitable for the uses of computer control system, and they are used in the numerical control or machine tools. Also it is a tape drive, floppy disk and printers, electric watches and X-ray plotters, robotics, and it has wide applications in textile industries and integrated circuit fabrications. And other applications of the stepper motor are in the spacecraft launched for the scientific explorations of the planet. And these motors are also find a variety of commercial, medical and military applications. And stepper motors of microwatts are used in wristwatches. In the machine tool, stepper motors are rating of several tons of kilowatts are used. So advantages and disadvantages of the motors are we can use advantages of excellent startup or reverse response. Rotation angle is proportional to the number of pulses. Broad speed range speed is proportional to the pulse frequency. And maximum torque we are using the stationary, and response that determines solely by digital input pulses, and allowing for open loop controlling, simplifying the motor structure and the control cost. And it is next advantage is highly reliable due to the absence brushes of motor. Lifespan depends only on bearing lifespan. So the disadvantages are challenging to operate at a high speed. Obtaining large torque is difficult. Risk of resonance if not controlled properly. Prone to losing steps when overloading, causing vibrations and noises at a high speed. So no advantages in terms of volume and weight with low efficiency and energy efficiency. Thank you all. See you in the next class.